Okay, homework's due today at 7:36. Make sure you're getting that wrapped up, turn it in today. I believe gradebook as of right now, other than these, it's all to date, everything's entered. So if you have missing like LIs or MIs from before, and you didn't turn them in, they're probably now either zeros or they're still saying LI. Like I made sure everything last night, if you had work turned in, it was all in, I made sure of it today. So everything in the gradebook as of this moment is up to date except for this one. I'm gonna try to put this one in over the weekend. I'll give you some papers today that if you want to like redo some old assignments, I'll give you those at the very end of class today because we're going to go through some stuff pretty quick today. I'm not going to spend a lot of time on the PowerPoint here. We're going to spend more time today on the practice guide for the test coming up. We have a test next Tuesday, so keep that in mind. I kind of warned you of that. So test is next Tuesday. And what? Okay. All right. So that's what we're gonna try to get to. If you want to log into your Nearpod, you can do that. SCVPX, that is a D in the middle. You'll need your notes, calculator, Chromebook, obviously, and then you need your practice test at the very end of class day. That was the practice I handed out yesterday. Did anyone not receive the practice test yesterday? Okay, I think everyone did. I think Mullins was the only one that didn't.
Hey.
Okay.
What was the code again?
Up there.
It says right.
Oh.
SCDP. Book checks, I've been kind of warning some class, I don't know if I warned you yet. Book covers, we're going to check books and book covers next Wednesday. That way it's well in advance before the end of the year. If you're missing it, you can go find it before it's too late. They're quite expensive, so don't wait until the last day to figure out that you've lost it. And it's $117 before I even sign you out. So right now I think it was $117. It goes up and down every day because of Amazon. So, but keep that in mind. Okay, today we're going to do a couple notes. We're going to fly through this today. We only have 3 terms to go through. I'm going to try to do a quick, really fast review of the stuff we did yesterday. And I'm just going to use the Nearpod that we did yesterday. So it's going to seem a little goofy that some of these slides are a little bit different from yesterday because I kind of updated it a little bit. But I want to do a quick review of what we talked about yesterday, just to make sure that you understand how to work those. Especially I don't know if we even proved 1014. I think I just showed you it and we just did a number. I want to show you that today. But then we have 3 new ones today, which are pretty easy. I think most of them have the same formula except for the first one. 1015 doesn't. That's kind of different compared to the other 2. But after we're done with that, we're going to do the first half review of your practice test. Well, I think practice has 13 questions. So we're going to go, I think, through set 6 today, the first 6 questions. So hopefully that makes sense. Questions before we get started? Okay, good. Hopefully you're logged into your Nearpod. We'll get started here in a second. All right. Let's click through some stuff. And again, apologies. Some of the slides are a little bit different. I didn't even think about updating Nearpod, but it's got the same information, but slightly different. Okay, so goals today. This is where it's going to be slightly different. I want to do a quick review of the definition of a secant tangent. I want to do that real quick. Then we'll just review that. We have to go through the 3 theorems we had yesterday. The 3 theorems were based on angles. So if you had secants and tangents crossing inside of a circle, then there are certain angles that occur, and they're using the arcs. New stuff today. We have theorems 10, 15, 16, and 17. Sorry, that's really small print. Hopefully it's showing up in your pod. This is slightly different, sorry, because I only started yesterday, so I didn't say review or anything like that. But homework today, jeez, this thing is all messed up, jumping around. All right, homework today that's due, that's your 7:36. But also we're going to go through that first half of our practice guide. So that's kind of our outline today, and then book check is next week. That's weird how that went all awry. All right, questions, comments about any of these? Perfect, okay. Now we have this, let's jump into it. What we talked about yesterday was on the Nearpod, we had the definition of a secant. Hopefully that's showing up correct. All right. Secants go through the circles twice. Now what we talked about yesterday is one of the new vocab words other than just a secant and a tangent. The actual item on the inside of the circle, it's called a chord, right? It's going from here to here. But what they actually call this in your book, they refer to it as a secant segment. It's the piece on the inside of the circle, secant segment. You can have secant segments on the outsides even. They're just, they call those external secant segments. So exterior parts. So you can have parts of like lines, but they're called segments. Questions on what a secant is. We're going to be using this a lot today, obviously. There's a couple of problems where they have tangents, like lines on the outside of the circles, but yeah. Okay. The first theorem that we had yesterday, this was 1012. 1012. I know it showed really weird on the near pod, and it's still doing it. I can't figure out why. But these were the formulas we talked about yesterday, that if you had this angle, you can actually, like if you had it, and you had one of the other arcs, let's say we had this arc, say this is 20 and 10, I better not use 20 and 10, let's go 20 and let's go 15. We can find this other arc down here, because I showed you the shortcut yesterday of how the middle angle, this angle here, it's not even the center of the circle like here, how this number is actually affected by these two arcs. Because what we talked about yesterday, so we did a problem where if this was 10 and 20, the shortcut yesterday is that the number, the angle on the inside that looks at these two arcs, because angle 1 is actually looking at both arcs there, it has to be the number directly in between. That was the shortcut. So what's the number in between 10 and 20?
15.
15, that was the number I just showed you a little bit. So that's this 15 degrees. And again, these are angles, by the way. That's the measure of the arcs, and that 15 can go here. And if you have that, then you can find the angle next to 15, which that angle would be angle number 2, because these have to add up to be 180. So this would be a 165. So that adds up to be a 180. And then, or if you had the two arcs for number 2, you do the same thing. These two arcs, the number here is the middle of them. And that works anywhere you put that thing, as long as the secants cross on the inside. Is there any questions with that one that we did yesterday? I think the shortcut really is kind of the easiest way to think about it. You know, you have the formula, obviously. You add the 2 and you divide by 2, whatever. It's the number in between them. I think that's the easiest way to think of it. Okay, are we good? Moving on. That was the one theorem that we had yesterday. Ignore this next slide on your near pod. Just ignore that. All right. 1013. Hopefully this showed up. Is 1013 on your... Okay. All right. 1013 is the one we did yesterday. This one is actually the reason why that last previous theorem worked. It was called a secant and tangent intersect. But what I call these are like inscribed angles. They're angles across the circle. They look at an entire arc. Well, in section 10.3 and 10.4, we talked about inscribed angles that when they look at an arc, they're always half of the arc, right? I think one of the previous examples we've done was something like this. You had an angle like this. This is what we did previously in chapters or section 10.3 and 10.4. That if that was 10, this angle had to be 5 degrees. Right? That was the concept. Well, that's what's happening here. Even though this angle's at the very bottom, or it's using a tangent and a secant, it still follows the same rules as inscribed angles, that it's exactly half of this arc. So if this arc was 40, then this angle that sits here has to be 20. It's half the arc that it looks at. Make sense with 1013? That one was like nothing new. It's just really nice to see that. This concept, what you're looking at right here, explains why theorem 1012 and 1014 work. We have to actually use that concept, this inscribed angle concept. Okay, we're good with that one now? And then what we finished with yesterday was this theorem. This is 1014. Okay, 1014 talked about, there was 3 different cases. You could have secants crossing, you could have a tangent and secant cross, you could have 2 tangents cross, but the big thing about this was that they're all intersecting on the outside of the picture. They're all crossing outside. And how do you find the angles? So what we talked about yesterday is the shortcut was to find angle A, this angle right here. You have to subtract these 2 arcs from each other. You actually subtract the 2 arcs it looks at. So it's like a periscope, right? Your eye is where A is at, and then it's looking through 2 different lenses, and then it sees an object on the other side of it. These 2 lenses basically make the entire angle where your eye is at. That's what develops like the distance you can actually see, especially with like the telescope. So what we talked about yesterday is that you can make up any 2 numbers you want. So let's make up 2 numbers right now. 32 and something smaller. 12. Okay, I'm gonna go 12. That was a nice number. So if you picked those two numbers, you subtract the two from each other. So 32 and 12. You actually subtract them big minus the small. And then whatever that answer is, you cut it in half. That is what this is saying. And what this will do is if you actually subtract the two arcs, and again, these are angles, that will give you this angle where angle A is at. So this is what, 20, and we cut that in half, and that'll be 10. And that's this angle here. That's 10 degrees for angle A. So it's not as easy as like the last ones we've done, where it was like, oh, it's always the middle number. It doesn't work that way. It's just the difference, and then you divide it by 2. Now, what we did not discuss was why. Like, how does this one work? That's what I want to talk about today. Okay? So I'm gonna get rid of these pictures to explain. I'm gonna draw a really, really big picture so you can see this. Okay? All right, so let's get rid of all this, and then I'll have you try one out by yourself. Okay, let's get rid of all these pictures. All right, perfect. Okay, so we have a circle, and you have these secants crossing on the outside. Okay, let's call this A, let's call this B, and C, and D and E. Okay, so now to explain why angle A is these two arcs subtracted from each other, the arcs that it's looking at through that like periscope, that telescope kind of thing. Okay? The trick is you draw a line from B to E, and this is something I think I hinted at that we were going to look at today. You draw this line so it makes a triangle. So you have this triangle right here. Okay? Okay, make sense? Okay. This angle, I'm going to put an X. That angle right there is on the outside of the blue triangle, correct? It's called an exterior angle. Exterior angles of triangles are equal to these two angles added together. That's what it is. So, angle X, the measure of X, is equal to the measure of angle A plus the measure of angle E. That's the concept. Okay? Now, angle X, though, just to talk about it, angle X is an inscribed angle. It's literally, its vertex is on the circle. It's looking at that arc. So, how do we find the measure of X using an arc? It's half the arc. So X, this X, is half the arc that it looks at because it's across the circle, right? That was that theorem 1013 we just looked at a little bit ago. That arc is DE. So angle X is half of whatever DE is, that arc. So if you had DE's arc, the angle of it, cut it in half, okay? All right, and measure of angle A, I don't have it, it's outside the circle, that's the one we're trying to find. We're trying to find angle A. But angle E, same concept. Angle E is an inscribed angle. The vertex is literally on the actual circle. It's looking at an arc. So just like before, it's half the arc that it looks at. So angle E is literally half of BC, the arc that it looks at. Right, if that was an angle. I should put an M in front of those, but you get the idea. All right, and to solve for A, all you have to do is subtract this over, and this will explain why this whole formula works. That you subtract, so we're going to measure of DE, we're going to subtract the half of measure of BC over, and this will equal the measure of angle A. So if I subtract that over, because when you bring it across equal sign, it's subtracting, and notice that they both have halves in common, so I can take out the half idea, because that's called factoring, that they both have halves taken out. That's measure of angle DE minus measure of BC. That you're actually, and that equals angle A. That you're actually subtracting the two arcs from each other, DE and BC. You cut it in half, and that will equal angle A. That's the whole concept of why it works. That's the definitive proof of why. But it's using those previous theorems that we talked about. Okay, now, that's all fine and easy and lighthearted. So, here's what I need. I'm going to give you this picture. Actually, I picked one of these three. Picked one of these three pictures. And what I'd like you to do is find angle A, the one on the outside. Okay, so here you go. Okay, so I picked one of these three. What you're going to do is you're going to find angle A. So let's say I picked this one. Okay, I don't know which one I picked. So let's say I picked one of these three. What you have to do is you have to fill in your own numbers on the two arcs, and then I want you to find this angle right here. So my example was I used 20 and let's go 15. Those are my two arcs. I subtract them from each other and then cut it in half. So 20 minus 15, and then cut that in half, and that's same on the outside. That's what I want you to do. So mine will be 2.5. And I want you to label your picture with the numbers, find the angle on the outside of the picture. Try that right now. Once I find some that are really good and submitted, then we're going to talk about it. So again, it's going to give you one of these pictures. And you have to find an angle on the outside. After this one today, I think this is the last one where I have you I think this is the last one where you make up your own numbers, I think. Yeah, I think the rest of them, they have numbers on the pictures from now on. Or I'll at least give you the numbers and the directions. All right, I know some people are still working here. All right, I'm going to share one because I like the numbers that were on it. So apologies if I didn't pick yours, apologies. Here's one that I like. Okay, very, very easy numbers. Okay, they have 10, 8. And they have to find angle A. And I believe the picture they have is that one, that middle one, this one. Okay, is that the picture you guys have? Okay, so they had 10 and 8 here. The trick is you subtract them, you get 2, and then you cut it in half, you get 1. Boom. Like it. Very easy numbers, quick and clean. There was only, I think, from the ones I was looking at, there was only one person that made a mistake. They had I think it was a 25 and a 15 here. They subtracted the 2, so they got 10, but they forgot to cut it in half. This should be 5. It's half of that 10. Okay. So it was half of what the difference is. Okay. Questions, comments about this theorem? Okay. The rest of these theorems today are not based on angles anymore. We're going to look at the segments, the actual lengths of the sticks now. So segment lengths. Okay. Are we good with all the angle stuff though? Pretty easy? I didn't feel like we needed homework on this stuff, because it's kind of stupidly simple. It doesn't really require that you need to do 50 different problems on this. Okay, 10, 15, here we go. Okay, new one today. I believe everything's showing up in your Nearpod. Again, on Nearpod, I think you can hold if you hold the control button, you hit the little plus sign by the backspace key. It'll zoom on your pictures so you can make them bigger if they're really tiny. But again, what this one says, 2 chords are intersecting in a circle. These could be secant segments. They could be the parts of the secants that we're crossing. But the lengths that are produced of the segments are actually equal. What I mean by that is that here's the picture you guys should be seeing. And they try to color code it. Sorry if you can't see that. But the idea is that each chord themselves is unique, right? Chords are different lengths depending if they're from the same center. But for some reason, every chord is proportional to each other. Because if they're in a circle, there's a limit to it. Like the biggest type of chord you can have is a diameter. The smallest one you can have is almost getting down to a single point. So there is a limitation to the sizes you can have. So they're all proportional to each other. So what this theorem says, and this is the formula that you should see on your paper, is you pick one of the chords. So the one that they picked this chord right here. They picked this chord. Does everyone see that it's made of two distinct segments, that chord is? It's made of the AB stick and the BC stick. These two. These two sticks are obviously different lengths. But all you have to do is multiply the numbers together. So if you actually had the lengths, whatever they are, let's say it's 2, let's say this is 2 and 10. If you multiply those together, so 2 times 10, that should equal the other stick doing the same exact math, even though the two sticks are different sizes. So the other stick could be, maybe the other stick is 4 and 5. And you do the math, and yeah, they should be equal, 4 times 5. So why this is important is because if you're missing one of them, you can find it now. If one of them is missing, you're golden. So the idea is that to solve this, so let's say this one was missing, right? The 5 was missing. So 4 times 5, or sorry, 4 times x, I should say, is equal to the 2 times 10. So you pick each stick separately. That's what this is saying. You multiply them together, so this is 20 equals 4x, and then you divide by 4. So your x should turn out to be 5. Makes sense like what we're doing on this. Like it's not really complicated, but again, the reason why this works is because the two sticks are actually proportional. That's why you can actually multiply pieces that are of proportions together and it still works out, they still balance. Do we feel comfortable if you had a problem like that? Okay, so on your Nearpod. I want you to fill in your own numbers. This is the last one, I promise you, this is the last one that you have to fill in your own numbers. So you get to pick any numbers you want, but make sure one of the sticks is missing. One of them. So you can make up any numbers you want. This could, most of the time these could turn out to be decimals. It's totally fine. So pick any numbers you want for each of these sticks, but one of the sticks is missing like I have. Like I have an X missing. And what you do is you pick one of the sticks, this stick, you multiply the two pieces together, and you set equal to the other stick multiplied together. And then you can solve. Once I see some answers come in, I'm gonna share one that I like that has kind of easy numbers on it, and try not to pick my numbers, but try to pick something different. I'll try to share one with you and we'll see. Some of these are pretty good.
How did you mess up? There's some times that we go there.
Okay, the one I'm going to pick, I'm picking Mitch's. I like that one. Okay. Here's the one that Mitch has. I like it. Easy, simple numbers, nice and clean. Okay, so if you look, he picked his marks that he had. He had, I believe, a 4 here. He had the X here. He had a 2 and a 2. 2 and a 2. Find n, because again, I told you you can pick any numbers you want. Fine. So, 2 times 2, that should equal the 4 times x, and you figured out this x had to be a 1. Perfect. Now, here's why I wanted to stress this. I like it. Easy numbers. Very nice. Now, look at the two sticks. A to C, E to D. The big sticks. Are the big sticks the same size? No. Even on his picture, they didn't have to be the same size. What I mean by that is like E to D here, that's 5 in length, if you think about it. That is 1, and that's a 4, that's 5. This one's only 4. But for some weird reason, according to this theorem, the math still works out when you multiply the pieces. Because proportions work that way. Proportions work for division and multiplication. They don't need to work for addition. They don't have to add up to be the same size stick. Some people, like in other classes, always get thrown off by that. Like the chords don't have to be the exact same length. But the math here, when you multiply them, they have to work out every time. So these could be decimals. Okay, are we good with this first one? Today, that was one of the new ones today. I think it's pretty straightforward. All right, let's move on. That was very good. For the most part, the pictures I had, they're all pretty good. So some people picked some really weird numbers. Okay, apologies. Again, that weird formula thing, they moved it up. I don't know why. It doesn't look that way on mine. But two secants intersect on the outside of the circle. Then what they're going to talk about is the secant segments and the external secant segments. There's a relationship there. So I'm just going to give you the picture. I want to discuss it. This one, now, you've got to think about what we just did in the last problem, right? The last 10, 15, and kind of forget about 10, 15 for right now. This is a brand new formula. This is a different picture. Okay. And the formula, yeah, they give you the formulas down off the bottom. Or, I don't know why they have it up here. It looks stupid. Whatever, I can't figure out in your pod. All right. So let's discuss. On this problem, what they're saying is that if you were to have, like you were to pick one of these secants, right, the secant segments, you pick the piece on the outside, so let's say I pick AB, and you multiply it on the whole secant, the whole segment length, the whole thing. That should equal the other stick doing the same thing. So the other stick, I would pick AD and the whole piece. Not the individual parts. So the external piece and the whole stick. So if one of these is missing, we can find it. So let me give you the math here. So let's say I'm missing AB. Let's say I'm missing the part on the outside for some reason. That's the part I'm missing. And I know the whole length of this stick is 12. I know that. The whole stick is 12. A to C is 12. So these could be any sizes. This could be 1 and 11. This could be 2 and 10. You get the idea, right? They're different sizes. This down here, this one, had a 4. And the whole stick here was, let's say it's, I don't know, say it's 9. Whole stick is 9. So it's 4 and 5 down there. So the secants are different lengths, right? One's 9, one's 12. But for some reason the math still works. That if you were to take the piece on the outside times the whole stick, so 12 times x, and you on the other one you take the 4 times the 9, you will get the answer for x. So the piece on the outside times the whole stick. So this is 12x equals 36. You divide by 12 and you get 3. And that's my x. So this has to be a 3. This has to be a 9 to make the whole 12. Does that make sense what we could do there? Now, the one thing I'm worried about, before I turn you loose and you try your own problem, they could do something like this. Let me just show you. I'm gonna leave this math up here, but this is what they could do to mess with you. For some reason, when this is the picture that is provided, some people don't think you can do the same formula. You can. You can take the entire stick times the piece on the outside. Well, what's the whole bottom stick here? 9 again, right? This whole thing is 9. Because you add the 4 and 5 together, and then you take it times the piece on the outside. It's the same problem I just did. You do not need to use the 5. The only part you need to use 5 for is to figure out what the whole stick length is. You have to use the whole stick times the piece on the outside. Does that make sense? Okay, I'd like you to try it. I'm going to leave this up here. This one, they give you the picture, I think it's the same picture. I did provide you the numbers though. So if you look at the directions, if you do that little drop down, it does provide you numbers for this picture. So it says certain lengths are provided, you have to find one of the pieces. So it's a very specific problem. Again, fill in the numbers, try to solve it. I'm gonna leave mine up here just so you can see this. Again, you're trying to find, I believe, BC in your picture, one of the sticks. Okay, that's your question, correct? The 5 and 16? Okay. Hope people are still working. Hopefully that's the numbers where you fill them in. I can give you a hint. You have to find AB first. Find AB using this formula. Then you can go find BC second. Okay, so it looks like for the most part, there's only, I think, 1 or 2 more people still working. Okay, so here's the first part. If you gotta find AB, call that X, you have to take that piece on the outside times the whole stick, set that equal to the piece on the outside times the whole stick. This turns out to be 20X, this turns out to be 80. That's 5 times 16. Divide by 20, and this is where a lot of people just stop. They said, oh, it's 4. Not quite. This is 4. What's that piece?
16.
This has to be 16. Now, don't read into it, don't look into this and go, oh, that's 16, this one's 16. Oh, there's a correlation there. This is the one that Ward just did a little bit ago. It's random. It just happen to be the same number as the stick on the bottom, but don't read into that. Okay, questions, comments about this problem? Okay, last theorem today uses this same math. It's the same formula. It's just the picture looks different. So let me get rid of that Nearpod you guys are looking at. Thank you for submitting. Okay, this is the last problem today. And we'll talk about your practice guide. Okay, so tangent, secant, intersect on the outside of the circle like this is a tangent secant. It has the same exact math. So this is the formula that's showing you on your paper. Now it looks to you like, Ward, that doesn't look like the same formula. Let me explain. When you did your math in the last problem, what do you do when you had a secant? What was the work you had to do? Like if you had this secant down here, what do you have to do with it? What was the math that was involved? What did we do in the last problem?
Multiply the whole thing by the outside stick.
Yeah, you take the outside piece times the whole stick, right? That's what you do. That's what you do to this one as well. You take the outside piece, well the outside piece just happens to be the entire stick, right? It's the whole outside stick. And then you take it times the outside piece, right? The whole stick times the outside piece. Well, it just happens to be the same letter. There was no inside. So it was just the outside times the entire stick. So that's what you're seeing here. That's why they're getting something squared. Because you're literally taking the item times itself. So this is, when I do this problem, this is what I think about. I just do this. W times itself, the piece on the outside times the whole stick. And that's basically what I think about. I don't think about X, Y's, and W's, but I think about just the logic. I don't even like think about this stupid little formula. I just think about how we did the last problem. And then you just solve it the same way. If you had to solve for W, that's fine. This is W squared, you just take the square root to the other side. If you had to solve for Y, fine. Divide by X across. It's the same math. This one just happens to have a square root on it. Okay, that's the last one today. So that's the last one I want to cover today. So what I'd like you to do is take out your practice test, your practice chapter 10 test. So I'll leave this on your Nearpod, so I'll leave that sit. I'm going to get rid of this for right now. It should be on your Nearpod, so you shouldn't have to worry about it. But let me get rid of this. I want to show you your practice guide. Okay, we're gonna start reviewing it today. It's fine if we don't get done today. I'm not expecting to even get remotely close to all 6 problems we had. I want to get through today. The goal is to just start the review today, and then we'll finish it Monday. This test is Tuesday next week, right? Which those last couple problems we shouldn't have to spend too much time. So maybe we'll get through the vocabulary today. Okay. Okay, so the vocab, it's going to be very short. Sorry I didn't have any lines. Maybe on test day I'll make sure I put lines back there and space it out a little bit. Sorry, didn't think about it. Okay, you're writing the words down next to the definitions. So radius is a line of a circle. It's a segment of a circle that connects the center of the circle to a point on the exterior. So, or maybe it's the distance from the center to the edge. Maybe that's the best way to describe it. Center of a circle is the exact point that is equidistant from every point on the outside. So that is a center. Tangent is a line in the plane of a circle that intersects a circle exactly once. That's a tangent. A point of tangency is that specific point where the line intersects the circle. Chord is a segment with 2 endpoints that lie on the circle. Segment that both endpoints lie on the circle, that's a chord. Sphere is all the points that are equidistant from a central point. Sphere and circle have the same definition, but it's not limited to a plane. Inscribed is an object drawn inside of a circle. So it's a polygon who can lie on the inside of a circle. Okay. You could use the word inscribed twice because I have it in the word bank twice on this one. Inscribed can also an angle that can lie on the circle itself. And the chords are the sides of the angle are chords of the circle. So you can use the word inscribed twice because I have 2 definitions of it. The word secant is a line that intersects a circle twice. Minor arc is an arc has a measure less than 180. Major arc is an arc that has an angle measure, or central measure of greater than 180. Central angle is an angle whose vertex lies at the center of the circle. That's a central angle. And then obviously we talked about inscribed. Inscribed has two different definitions. You could have polygons that are drawn inside the circle where all the vertices lie on a circle, versus you could have angles that are inscribed, because an angle would have a vertex on the circle and the sides are chords. So inscribed can be used twice because there's 2 like radically different definitions. I'll probably stop there today. We'll pick up tomorrow. We'll just kind of go through this stuff. So.